Hey everyone, so today we are gonna not do anything new, but I really wanted to talk about the different methods that we've used for graphing and how to find the vertex giving each, how to find the y-intercept, how to find the roots using each method. Alright, so pause and try the do now. If y equals kx, where k is a constant, and y equals 24, when x equals 6, what is the value of y when x equals 24? So anytime they give you just like values, just try plugging in. So we have y is 24, and then it gave you k, and then x is 6. Well, based on that, what do we know? Divide by 6, k has to be 4. What is the value of y when x is 5? So y equals, well, we just figured out k is a constant, right? So k is 4, and x is 5, so 20. That's it. Very straightforward. Just like try stuff, right? Don't just give up, oh, this looks confusing. Try something. Okay, so I know, in your own words, describe the following in terms of the equation and in terms of the vertex, or in terms of the graph, sorry. All right, so pause and try that. So the vertex is the lowest or highest point on a graph. It's also called the turning point, and it's the symmetric point, right? And then we use it to find negative b over 2a. So on the graph, the vertex is this point, right? And there's lots of ways to find it. What are the roots? The roots are where the graph crosses the x-axis. Oops. Crosses the x-axis, and the solutions when you set the equation equal to 0. Right? So graphically, it's these points right in here, right, where it crosses the x-axis. It crosses the x-axis where y equals 0. Right? And then the y-intercept is kind of the opposite. It's where the graph crosses the y-axis. And then x equals 0. Right? So for that one, we would do, here's our parabola. This would be our y, that point. Okay? It's where it's crossing the x-axis. That's a bad picture. I'm going to erase that. I don't like it. I'd rather have it be something like that. Where is it crossing? It's crossing right there. Okay, so what are the three forms of a quadratic that we have learned? So we started with standard form. What is standard form? That's just a regular equation, right? I gave these to you, we know how to factor them, right? So for example, y equals x squared minus 4x minus 5. No parentheses anywhere. It's just the parabola multiplied out. Factored, right? Think about what factored form looks like. That's where we have parentheses, right? That shows the roots, right? Factored form is where it's showing us our roots. In this case, m and n are our roots. And then vertex form, that's the one we haven't done that one in a little bit. So that is where you have the parentheses squared and then a number, right? So for example, this one. So all of these have positives and negatives for solving and graphing. So the easiest one to graph would probably be number 3, as long as you have integers. Number 2, it's really good. That one's really nice for showing you your roots, right? I can just kind of look at it and I know my roots. And then standard form is good because, when all else fails, if you have, especially if you have gross numbers, you can just go back to using a table, negative b over 2a, that kind of thing. Okay, so now I want you to find the vertex of each parabola. So think we have different methods for each of these. So pause the video and find your vertex. All right, so number 1, to find the vertex, we're going to do negative b over 2a. So let's see, our b value is negative 8, so I'm going to do it over here. So negative 8 over 2 times 1. So remember that 1 is your a, and that's your b. 8 over 2 is 4. So my vertex is 4, comma, and then how do you find your y value? You find your y value by plugging in. So we're going to substitute in. So I've got 4 squared, 8 times 4 plus 15. And just grab your calculator. You can put parentheses around that if you want, because it's positive. It's not a big deal. And I got negative 1. That's it. Done. All right. How do we find the vertex when it's factored? Now, if you're really, really stuck on a test or a quiz, you could multiply it all out, like distribute everything, and just do your negative b over 2a. But that's a little more complicated. So to find the vertex here, we're going to find the roots first. So what are the roots? The roots are negative 5 and 11. Right? We switch the sign. We set x plus 5 equal to 0, x minus 11 equal to 0. Now, why do we do that? Because parabolas are symmetric, right? So if that's my parabola, my roots are here and here. The vertex is halfway between. So now we're going to take our roots and find their average. Negative 5 plus 11 divided by 2. 6 divided by 2 is 3. So my vertex is 3, comma, and then how do you find your y value? Again, we plug in. So I'm going to do parentheses instead of x, 3 plus 5, 3 minus 11. And again, you could just plug that in your calculator. You end up with 8 times negative 8, which is negative 64. Done. So we find our roots and we average them. And number 3, that's the easy one. The vertex form, this is vertex form, right? Whenever you have something squared, minus, or plus something. So the vertex here is just negative 7, negative 4, right? So this is called vertex form, so we don't have to do anything. Change the sign of the inside, because we want to, what would make the inside 0? Negative 7 plus 7 squared. That whole thing is 0, and then you're left with negative 4. All right, now it's the same 3 problems, but this time we're going to find the roots, or the zeros. So set each of them equal to 0 and solve. So 0 equals x squared minus 8x plus 15. So go through, pause, and do all of these. So now this is a factorable problem. How do we factor x squared minus 8x plus 15? That's a multiply and combine. We're multiplying to 15, combining to negative 8. 3 times 5, but they both have to be negative. So we end up with x minus 3 and x minus 5 equals 0. And then to find the roots, we set each equal to 0 and solve. So all we end up doing is changing the sign. So x equals 5. School starting. That's it. So number 2, this is the easy one, right? And the last one, for vertex, the number 3 was the easiest. For roots, number 2 is the easiest, because we're just setting this equal to 0. But it's already factored for us. So all we have to do is say, oh, x plus 5 equals 0. X minus 11 equals 0. Change the sign, negative 5 and 11. Right? Number 3, now this one I personally think is the most difficult. Right? So number 3 is the hard one. So we're setting this equal to 0. I promise not to make these too complicated though. So what do we do first to solve for x? We add 4 to both sides. 4 equals x plus 7 squared. Now we're trying to solve for x, so we need to get rid of the square. How do you get rid of a square? The opposite of a square is a square root. Remember though, when we do that square root, the square root of 4 is 2, but we have to put plus or minus 2 equals x plus 7. Then I'm going to minus 7 on both sides, but you're not allowed to combine those together. So we have negative 7 plus or minus 2. So that becomes x equals negative 7 plus 2 is negative 5. Negative 7 minus 2 is negative 9. And those are our answers. So number 3, well, it's easy for the vertex. Algebraically, it's a little more complicated to find the roots. And then the last one is our y-intercept. So this one, number 1, is the easiest because what do we know about the y-intercept? X equals 0 when we have the y-intercept, right? The y-axis, if this would be a y-intercept, right? The x value is 0 on the y-axis. So all we're going to do in all of these problems is plug in 0. So pause and do that. So number 1, y equals 0 squared minus 8 times 0 plus 15. So this is the easy one because it's always just that last number, right? Our c value is our y-intercept. This one isn't necessarily hard, but it's a little more work. Again, I'm substituting in for 0, and I end up with negative 55. And then vertex, again, it's not overly hard. I would recommend using your calculator. It's just a little bit more. It's just an extra step. 40, whoops. 4 does not change. So 45. Y equals 45. And that's it. Okay, so now I want to fill these out. So pause and see if you can figure out, just kind of in your own words or formulas, what would you do? So when you're in standard form, that's your y equals ax squared plus bx plus c. What do we do to find the vertex? We do negative b over 2a, and then plug in.
Good morning.
Sorry, we had announcements. I got distracted. So number 2, plug in to get the y. All right, number 2. So to find the x, what do we do? To find the roots, what do? We factor and solve. Or, in rare occasions, we have to do quadratic formula. If I give you a hard one, sometimes you'll have to do quadratic formula. Y-intercept, it's just the c value. Other, I don't really have anything for other. I'm just going to put a smiley face. All right, factored form. Y equals, I think I called this a, x minus n, x minus m. Oops. So how do we find the vertex? Find the roots. And average. Right? So that's n plus m divided by 2, if you don't know what average means. And then again, plug in to find y. The roots, so this is already factored, so set each factor equal to 0. y-intercept. Sorry, my brain stopped working. Plug in x equals 0. And that's the case for every y-intercept. So just kind of keep that in mind. Plug in to find your y. So it's going to be different every time. And then other, do I have anything good for other? Sometimes the y-intercept is the root. That happens sometimes. All right, last one, vertex form. So this is y equals a x minus h squared plus k. The vertex is h comma k. Change the sign on the inside. Change sign inside. Outside stays the same. The roots are tricky, right? So roots are set equation equal to 0. Get parentheses squared alone. Square root. And then solve for 0. Or solve for x. So that one's more complicated. For other, we'll put an example. And then y-intercept, again, just plug in x equals 0. Right. So for example, if I have 2 times x plus 5 squared equals 8. Or, sorry, minus 8 equals 0. Let's put an example here. So I'm going to solve for, I'm going to add 8. 2 x plus 5 squared equals 8. Divide by 2. So that I isolated, right? And then we take the square root. X plus 5 equals plus or minus 2. Don't forget the plus or minus, and then minus 5. X equals negative 5 plus or minus 2, and then you can figure out negative 5 plus 2 is negative 3. Negative 5 minus 2 is negative 7. Right. So don't, maybe in other, if you want, you can put don't forget the plus or minus. All right, last slide. I want you to find all of everything, right? So I've got one standard, one factored, one vertex form. So go through and find everything. These are a little bit on the challenging side. At least the first 2 are. All right. Vertex. Okay, so negative b over 2a, so negative 6 over 2a. Uh-oh. So this is 6 over 4, 3 over 2. All right, so for my vertex, I get 3 over 2, comma, roots, y-int. Okay. Now just plug in 3 over 2 into your calculator. I got 6.5. Right? So I did 2, 3 over 2 squared, 6, 3 over 2 plus 11. All right, y-intercept, plug in 0. Right? 0, comma, 2 times 0, 6 times 0 is just 11. All right, roots, 22. This isn't factorable. We have to do quadratic formula. All right, so let's do the quadratic formula real quick. Negative b, negative 6, negative 6, negative b, plus or minus the square root of b squared minus 4ac all over 2a. Why did I use this? I don't think this has roots. Maybe I probably did that on purpose, not gonna lie. Minus 4 times 2 times 11. Negative 52. So I get 6 plus or minus the square root of negative 52 all over 4. So that the roots are NA, right? This does not cross the x-axis. If you think about the graph, I'm going to draw it down on the bottom. So I have the point 1.5, 6.5, and then it's upward facing. That's my graph. Notice it never crosses the x-axis, so there are no roots. They're called imaginary. All right. So that one was a little tricky. All right, try the next one. All right, at least the vertex is easy on this one. So my vertex, change the sign of the inside, outside stays the same. My roots are going to be the ones that are gross. Okay, so we're setting this equal to 0. Use green. So 0 equals 3x plus 2 squared minus 7. I'm going to add 7 and divide by 3. Square root of both sides. X plus 2 equals plus or minus the square root of 7/3. And then I'm going to minus 2. So I get negative 2 plus or minus the square root of 7/3. We haven't talked about rationalizing the denominator yet, so we're just going to leave it like that. And then the y-intercept. My y-intercept, we're just going to plug in 0. So y equals 3 times 0 plus 2 squared minus 7. So that's 3 times 4, so we get 5. All right, use the calculator, please. You guys always make silly mistakes. All right, last one. So vertex, roots. So in this one, the roots are easy. What are our roots? Negative 7 and 4. And then how do we find the vertex? We add them, divide by 2. So negative 3 over 2. So it is a fraction, and then plug in. So negative 3 over 2 plus 7, negative 3 over 2 minus 4. And you can plug this exact thing in your calculator, and it'll work. I got 30.25. 30.25. All right. And then the y-intercept, we just plug in 0. Oh no, I made a mistake. Oh no, I didn't. Make sure you put your negative out front. I almost forgot that. So 0 plus 7, 0 minus 4, so we get 0, 20, positive 28. Be careful when you have something in front to put that. And that is it. All right, have a fabulous day. I will see you. I'll see all of the blah, 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 blah. You know what? Let's check your notes. Draw a house. This is a trick. I don't know if you guys know. Can you draw that without picking up your pencil or going over any itself? There's a way to do it where you can draw it, but you can't pick up your pencil. Can you do it? I did it in one way. Can you do it in another way? There's your hint. There's your challenge problem.